Our final example is what's known as rationalizing the denominator. So it basically wants to get rid of, when we're rationalizing the denominator using this, it wants to get rid of any radical in the denominator of the expression. In order to do that, we have to multiply it by its conjugate, or create a conjugate. So in other words, the denominator has to be multiplied by, instead of 1 minus 4 root 5, it becomes 1 plus 4 root 5. But you have to multiply this expression, both numerator and denominator, by the same amount, because otherwise you change the expression. So in other words, you multiply also the numerator by 1 plus 4 root 5. So in this example here, you're running into the scenario where you have to generate a integer denominator by conjugating or using a conjugate. So then we go ahead and do the expansion. The numerator expansion is the more complicated one, because you have to multiply every term. So you've got 3 times 3, which is 3. And then you've got 3 times 4 root 5, which is 12 root 5. And then you've got 2 root 5 times 1. So that's plus 2 root 5. And then 2 root 5 times 4 root 5, which is, that is 8. So that becomes plus 8 times root 5 times root 5 is 5. Any radical times itself. Now, what happens in the denominator? Well, similar to difference of two squares when you work with quadratics, with radicals, what ends up happening is you just need to multiply it times the first term times the first term, and the second term by the second term. So it becomes 1 times 1 is 1. And 4 root 5 times negative 4 root 5, which becomes 16 times 5. So now we have it simplified in that way, but it's no longer addition. Now it becomes subtraction between the two, because you're multiplying a negative times a positive. And then it's just a term of all you have to do then after that is simplify. So I know I have in the numerator, I've got 3 plus 40, which is 43. Then I've got 12 root 5 plus 2 root 5, which is 14 root 5. And then the denominator becomes 1 minus, once again, 16 times 5 is 80. So that's negative 79.